How's it going? I'm Andrew Hill.
I'm Zernika Hajiski.
I'm Imran Ananto.
And we're going to talk about our project for COEN 4790, Developments in Computer Hardware, with Professor Dr. Kristinella Bave. So to kind of get into it, before we show you our actual demo, I'm going to kind of briefly touch on what is network on chip. So network on chip communication is essentially intercommunication between different processing elements. This is kind of breakthrough technology that allows for heavier workloads and quicker communication between elements, other than basic topologies that exist today, such as a bus or a grid. So it utilizes network concepts. So each processing element gets its own router, and those routers can be connected to other routers in any kind of topology, so star, ring, whatever. And then the actual data, which would normally be called a packet, is actually called a flit, and those flits can actually traverse the network, be sent from one processing element to the other. A typical router consists of an input unit, one for each direction, so north, south, east, and west, and then another unit for the local processing element. And then those are connected to all the other routers, and then you have routing configuration, virtual channel allocation, and then switch allocation. Those mechanisms help the data actually update the proper field so it knows where it's going. Then you also have the crossbar switch, which actually brings the data into the correct. So if you're, say you come in from the north terminal and you want to go south, the crossbar switch will actually take that flit and actually so it'll give it to the right output. And then you have an output unit which updates any of the fields necessary for the flit to continue. So I'm going to go ahead and hand it off to Zora and Imran, who are kind of show the demo of our final project, which is a 2x2 mesh network on chip. Hope you enjoy.
Okay, so the design that we have developed, so it starts by sending some data to the FPGA board by using serial communication. So we have implemented the UART class of that came with the manufacturer. So we basically start with giving it a head flit, a body flit, another body flit, and a tail flit. So just for the ease of this presentation, I've copied down like the data that we have selected to work with. So as you can see, I'm copying this, giving it to the head. So this button turn on, that's a 32-bit head flit. We're sending it, and as soon as we send it, you will see.
Once he sends it, you can see it right here. So he just sent the first flit in, and this is the head.
Yeah.
And as he continues on with the body.
So then I'm sending you body flit. That's the same.
And it continues to stay here
That's
until.
That's the third body flit. That's what I'm sending. And finally, I am sending you the tail flit.
And
Okay.
here we've already passed through 4 cycles, and it's passed so far through the router configuration and the virtual allocator, also the switch and the transversal.
Okay. And I'm going to kind of chime in here. So you should see we've added a manual clock tick,
Yeah.
so that way we can actually step through the program.
Yeah, because this whole process, it can go super fast, so we want to show it step by step. That's why we added this button. It's a trigger clock. So every time you're doing this, you're basically triggering the clock.
And
so
every
we go
time
step by
the
step.
clock triggers, you can see a flash right here.
It's very faint. I don't know if the camera can catch it. Okay. We'll kind of jump back to this. So the reason we have these LEDs here is to show it as it traverses from each router. So that would be router 1, 2, 3, and 4. So Imran's going to just kind of click through here. You can go at your own pace, Imran.
And here it already passed the entire router 1.
There it goes. Oh, there we go. 4. And it's going to head south. Okay, and as it starts to get to the router 1 again, it should go loop around. There we go. Awesome. So I'm going to kind of focus back in here, and Imran's going to explain when the output finally comes back.
Yeah, so all this time I've been just triggering the clock. So finally at this time we should be able to see the output.
Oh, there
We
go.
go.
we
So
finally-
that's flit form.
Yeah, the first head flick came
Yeah,
back.
nice.
Going through.
Followed by the
Second
second, which is working good.
Third,
That's the third one.
and
And the
fourth.
final.
Final. Okay, and then to quickly explain this, you can see our first body flit contains the value 3.
Yeah, the 3. There we go.
Counted to
So that's
3.
a success.
All right.
Yeah, there you go.
That was our 2x2 network on chip. Thank you.